a little bit today, and then we'll do the third one, which is elimination. We'll get into substitution a little bit more in depth tomorrow, and then we'll talk about some elimination tomorrow as well. But to start off with, you're going to see a couple of problems like this today. Is -1, 2 a solution to this system? And so what we have to end up doing is we have to take that ordered pair, we have to plug it into both equations, and we have to verify if it works. And it has to work for both. It can't just work for one and not the other. So we know that in an ordered pair, this is always x and this is always y. And so we're going to plug it into both. And so the first one is going to be -1 minus 2 equals -3. So we would say yes. But we can't stop there. We can't say, oh, yep, it works. It has to work for both. We did that earlier in the semester where we only had one equation. And now we have two equations since it's a system. And so then we're going to do -1 plus 2 equals 1. And so since we say yes to this, then we would say yes, it is a solution to the system. And then what they're going to do is they're going to keep giving you different systems. And so let's look at another system. 3x plus 4y equals 6. X minus 4y equals 8. Okay, and in this case, kind of like what we did just a second ago, is -2, 3 a solution? Each system is a little bit different. Different numbers, different types. Sometimes you'll have some in slope-intercept form. Sometimes it'll be in standard form. All the different kinds. So here we're going to do 3 times -2 plus 4 times 3 equals 6. So this would become -6 plus 12. That equals 6, so we would say yes. The first equation, it works. Okay, for the second equation, we're going to go -2 minus 4 times 3 equals 8. So this would be -2 minus 12 equals 8. Bless you. And that's a no. So because that's a no, then we would say no here. Okay. That is not a solution. So you can see where it works for one and not the other, so it has to work for both. Okay, so we can't stop once we say yes on the first one. We have to check both, and we have to say yes for both. Okay, so that's just kind of like an intro into what is a system. How do I know if the ordered pair is a solution? So as we start going through these, what we're going to end up doing is we're going to get a solution, okay? If the two lines cross, we're going to get an ordered pair. And so what you could do is you could always plug it back in and verify that it works. We've always said that if I have an equation, I should always be able to check my answer, right? And so that is still true today. In order to check it, you'd have to plug it into both. But I could still verify that my answer works. So that's still good news that we can check our answer out. Okay, I'm going to put up some graph paper here because we're going to do a lot with graphing today. And using graph paper is probably a pretty good idea for these because we want our lines to be pretty perfect, right? Because what we're going to be trying to find is we're trying to find out where the point is where they intersect. And if my line gets off just a little bit, if I don't connect them together just the right way, then my line starts to get off a little bit, and then I'm going to have a really hard time trying to determine where they cross at. So I would highly recommend using a piece of graph paper to do some of these. So in this first one here, we're going to start with y equals 2x plus 5 and y equals negative x minus 4. I'm going to do them in two different colors so we can see the different lines and we can see what happens. Now, we have already graphed these lines before, so graphing it is something that we're going to continue to do here. Both of these are in slope-intercept form, so the good news here is we can just graph right away, right? So let's start with the one on the left, 2x plus 5. If I'm going to graph 2x plus 5, where am I going to start at on my graph? 5, right? And 5 is going to go where? The y-intercept. We've got to go up 5. We're going to make a point. Okay, that's my y-intercept. That's my b value. My slope is 2 over 1. So from that point, we're going to go up 2 over 1. We could also go down 2 and left 1. I like to continue this line on and do multiple points. I don't know where the other line's going to go yet, but the more points I have, then it's going to be easier to find that intersection point. If I just do 2, it's not wrong, but I want my line to be as exact as I can possibly make it. So we're going to connect all of these together. If we need it to go further, we can, but we'll stop right there. Okay, negative x minus 4. My y-intercept, my b value, is negative 4. So we're going to go 1, 2, 3, 4. And then we can go down 1, right 1, because my slope is negative 1. But as you notice, what's happening is if I keep going down 1, right 1, I'm going away from the other line. So instead of going down 1, right 1 continually, I can also go the opposite direction, which is up 1, left 1. Up 1, left 1. Up 1, left 1. And then there we are. We see a point that those two lines have in common. And that's a good thing, okay? We're seeing that these two lines are crossing. We can identify what that ordered pair is. Okay, and so then we're going to go name that ordered pair. So we're going to go left first. 1, 2, 3, down 1. So our ordered pair here would be negative 3, negative 1. And that would be our answer. Okay. If we had to, we could plug it back in, right? And I'm not going to do this for every single one, but just for this first one, just so you can kind of see how you could check this. If I take negative 3 and plug it in, 2 times negative 3 is negative 6. Negative 6 plus 5 is negative 1. Sure enough, right? And then I can do it for the second one. Negative 3, in for x. Negative 1 times negative 3 would be positive 3. 3 minus 4 is negative 1. Okay? Both of them work, both of them check. Sure enough, we have the right ordered pair. Okay? And so that's why you should never miss one of these. Can you put this into the calculator? What do you guys think? Can we put this in the calculator? Absolutely, right? And we have a function on the calculator that actually finds this. But here's what I'll tell you. On like the quiz or an assessment for this, you're going to have to be able to graph it, okay? So if you can put it in the calculator, that's great, but you're still going to have to be able to put that graph onto a piece of graph paper and show exactly where they cross. But your calculator can definitely help you with that, okay? And it should show you where it crosses at. Unfortunately, not all of our equations are going to be nice slope-intercept form. It'd be nice if they were all in slope-intercept form to start with, right? But they're not going to be. So let's look at another example here. Okay, this one I'm going to give you two equations. Let's do a different color here. X minus y equals 3. Both of these are in what we call standard form, right? We've talked about standard form already this year. We talked about a couple of different ways that we can graph these. Now I cannot put this into my calculator. So if you really, really want to put this into the calculator, which I'm guessing a lot of you probably will, what you're going to have to be able to do is you're going to have to be able to solve this equation for y. Okay? And if I can solve it for y and solve it correctly for y, then I can put it in my calculator and life's good because I have my calculator to help me out. You can do the cover-up method because we've talked about the cover-up method for this already, and the cover-up method is okay, but you're not going to be able to put it in the calculator if you do the cover-up method. Okay, so you kind of got to decide where you want to go with it. Okay, so let's say that we solve for y. This one is not overly difficult to solve for y. I'm going to subtract x. So I get y equals negative x plus 5. So I'm going to go up 5, make a point. My slope is negative 1. So I'm going to go down 1, right 1. I could also go up 1, left 1. I'm just making a bunch of points here because I don't know where that other line is going to come in yet, since we haven't even talked about that other line. So there's our line. If I had done the cover-up method here, if I cover up y, because I put 0 in for it, 0, 5, and 5, 0 would be my two intercepts. 0, 5, and 5, 0. So getting the y-intercepts and the x-intercepts is one way to graph it. The good thing about putting it in slope-intercept form, I can get a bunch of points really easily. So my go-to probably would be slope-intercept form here, but you could still do cover-up method. Hey, as I solve the second one here, I'm going to subtract x. And I'm going to divide by negative 1. So that's going to give me y equals negative and a negative, make that a positive x minus 3. So we're going to go down 3. And then we're going to go up 1 over 1. And once we can see that the two lines are going to cross, then you don't need to really continue to make a bunch of points. In this case, we're going to go over 1, 2, 3, 4, and up 1 to get that point right there. So we would say that our ordered pair would be 4, 1. Okay. But you guys can see why using a piece of graph paper is going to be pretty important, right? If I just tried to do this like on one that I made myself, then it's going to be really hard to kind of decide how far over and up did I go. And I'll get you some graph paper for your assignment today that you can use. That'll make it a little bit easier for you. Okay. The other thing we're going to talk about today, over here, but if there is one solution, anytime there's one solution, we call this a consistent independent system. Independent just means that the two lines are totally independent of one another. They have different slopes, they have different y-intercepts. Independent kind of means to kind of be your own self, right? And that's what these two lines are. They're kind of their own lines. The only thing they have in common is one point, and that's what makes them consistent. There is that point. Is different types of solutions. Two x minus y equals 3. 2x minus y equals 8. If I solve both of these for y, if I try to get y by itself. Now, I'm going to show you a little bit of a trick here, especially because it's a minus y. A little bit easier way to solve this is move the y here and subtract 3 from the other side. Okay, that's going to be the quicker and easier way to solve this one. Then we don't have to worry about dividing by negative and all that stuff. So I'm going to add y first, which is a little bit out of the norm. And then I'm going to subtract 3. If you want to subtract 2x and divide by -1, it's the same thing. I just think that's a little bit easier, a little bit less work involved. And remember, your y doesn't always have to end up on the left. It's not an inequality. If it's an inequality, we probably want it to end up on the left. Same thing here. I'm going to add y. And I'm going to go ahead and kind of combine 2 steps into one here. I'm going to subtract 8 at the same time. As I look at these two equations, what do I notice about them? Both have a slope of 2, right? What does that tell me? What do we know about two lines that have the same slope? They're parallel. They're never going to cross, right? And I'm not going to put this on a coordinate plane, but we would go down 3, and then we'd go up 2 and over 1. We would have two lines that never are going to cross, okay? And so we say that these two lines are parallel. And so here we would say that there is no solution. There is no point where these two lines will ever cross. They also have different names for these systems, and you're going to see these names off and on. So I'm going to kind of introduce you to these names. If your solution is no solution, then we call that an inconsistent system. It's a system that's not consistent, right? The prefix in means not. So not consistent means no solution. So if you know what the prefix in means, then you can kind of put 2 and 2 together here. Not consistent means there's not a solution. I didn't talk. Okay, the last type that we're going to see, 3x plus y equals 4. 6x plus 2y equals 8. We have two equations, system of equation here. I want to try to determine what kind of system, what kind of solution do we have. Once again, if you solve for y here, you'll easily see what's going on here. So I'm going to subtract 3x. So now that one's in slope-intercept form. Over here, I'm going to subtract 6x. And then I'm going to divide by 2. Okay. And we don't necessarily recognize it at the beginning because the two look like they're completely different equations, right? But now once I've solved it for y, what I notice is not only are they parallel, but they also have the same y-intercept. So these two lines are actually the exact same line. And we didn't necessarily notice it when it was in standard form. Okay? But as I solved it out, now I can easily see that those two are the same. So you have two equations, but you only have one line. And the reason we only have one line is because the two lines are right on top of one another. When I graph them, everything is in common. All their points, all their y-intercept, their slope, everything about them is the same. So we can't see the second line because it's right on top of the first line. And so then what we're going to say here, this is what we call infinitely many solutions. From here on out, I'm going to call that IMS, infinitely many solutions, just kind of a shorthand version or way of saying that. That's kind of usually what I do. You won't probably see the textbook call it IMS, but it's easy. I'm okay with you doing that. The type of system this one is is it's consistent because there's a solution, but it's dependent. Which means one point depends on another, because these two lines, everything depends on each other. Everything is in common. So it's dependent instead of independent. They're not totally independent of one another because they have everything in common. Consistent just means that there's a solution. So there's another reason why inconsistent means no solution. Consistent means there's a solution, just happens here that there's a bunch of them. Any point that falls on that line is a solution, and there'd be a bunch of them. Okay. The last system that I'm going to show you here kind of goes back to what we saw a little bit last chapter as well. We have x equals 4. We have y equals negative 2. And if I graph the line x equals 4, what kind of line is x equals 4 going to make? It's an undefined slope. So what's it going to look like? Straight up and down. It's going to be a vertical line. So I'm going to go over 4. It's going to cross the x-axis at 4. So it's a vertical line at 4. Y equals negative 2 is going to cross the y-axis, and it's going to cross it at negative 2. Okay, so these two lines cross one another, right? This one's probably the easiest of the bunch, because where do you think they're going to cross at? 4, negative 2, right? Because we already know the x value, we already know the y value, so the place where these two cross are those 2 points written as an ordered pair. Okay. But it's just another type of line that we talked about and that we will continue to see sometimes. Okay, I'm going to do a couple of real basic substitution problems here today, and then tomorrow we'll get into some of the more difficult substitution ones. So this is our second method. Graphing is our first method. Substitution will be our second method. And we'll continue talking about substitution tomorrow, and then we'll add elimination in there as well for day 2. System of equations. Whenever we do substitution, we must isolate a variable, and what that means is we must get a variable by itself. So the ones that I'm going to show you for today are already going to have that in place. Y is equal to 2x. Y is by itself. There's nothing over here with the y, right? So y is already by itself. It's already isolated. So what we're going to do is we're going to take 2x and we're going to plug it in for y in that first equation, because they equal each other, right? So we're going to simply substitute it in. 2x is going to replace the y because they equal each other. So we're going to rewrite 3x minus 2x equals 2. 3x minus 2x is 1x, so x equals 2. And if x equals 2, remember your answer today for most of these is going to be an ordered pair. Where do they cross at? And so all that we've found here is x, so we're not quite done. So now I got to take 2, I got to plug it into x. And you can plug it into the first or the second one. Doesn't matter which one you plug it into. Which one would be easier to plug it into, though? Second one. By far and away the easier one to plug it into, right? This one is going to get a little messy. This one's a piece of cake. Plug 2 in for x. 2 times 2 is 4, so y is 4. Shouldn't take much time at all. And that's our ordered pair. Once again, if you want to check it, you could check it. With substitution, we are not graphing it, okay? And one of the reasons why we do substitution is because, number one, it's easier to solve it that way in a lot of those cases. Secondly, graphing it could get a little bit messy in some cases because you start looking at like fractions and decimals and things like that. So it's a little bit tough to do. All right, let's look at one more, and then this will be it. X plus y equals 1. Y equals negative 2x minus 1. Okay, so the only ones that I'm giving you today, when we talk about substitution, we always want to get a variable by itself. And it could be x in some cases too. We might get x by itself in some cases. But here, because y is already by itself, then I'm going to take this expression, negative 2x minus 1, and I'm going to plug it in for y in the equation up above. So it's going to look like this. X plus negative 2x minus 1 equals 1. X plus negative 2x would be negative x. And then we're going to add 1. And then we're going to divide by negative 1. Okay, so we now know what x is. And then I got to plug it in. Once again, you have a choice. You can plug it into the first or the second. Okay. Usually I'll pick the one that already has a variable by itself. I'll pick the one that has y by itself. So I'm going to plug negative 2 in here for x. Negative 2 times negative 2 would be 4. 4 minus 1 would be 3. Negative 2, 3 would be our answer. This would be a really easy check. Does negative 2 plus 3 equal 1? Yeah, okay. So it wouldn't take long at all to check that one. Some might take a little bit longer than others to check. So I would highly encourage you to always do that, especially on like a quiz or a test. Because you have the ability to do it, then why not verify that my answer really does work? And if it doesn't, then I know I got to go back and figure out what did I do wrong. Okay, assignment for today. Just the evens, and I think it says, like on the ones that you actually have to solve, what method to use. Today is only graphing and maybe a little bit of substitution. I think there's one. Let me look at it real quick here. Okay, on 16 and 18, all you're doing is writing the equations out. And it tells you that. Translate into a system of equations, it says do not solve. So we're not solving them yet. We'll solve later on, but all they're doing there is trying to get you to practice setting up in a system of equations. So 16 and 18, you're not solving it. 8 through 14, you're just checking yes or no it works. 20 through 28, you're graphing it. And then on that last group, through 44, you are doing substitution. Okay, I'll get you some graph paper here.
Thursday, I'll send them to